Hey everyone, welcome back, and let's write some more Leetcode today. So today let's look at Leetcode 88 merge sorted array. So we're given two input arrays, nums1 and nums2, and we want to take nums2 and then merge it into nums1 into one sorted array. Now, lucky for us, we are guaranteed that there is enough space in nums1 for every element in nums2 to be inserted. And we want to make sure that they're in order. Now, what if you just want to kind of be lazy? Let's say you got these input arrays, nums1 and nums2. It seems kind of annoying having to merge them into nums2. What if we want to be really lazy? We can just create a fresh copy, a fresh empty array with the same number of elements as nums1, and then we can start at the beginning of each of these arrays, nums1 and nums2, take the smaller element, insert it into the new array, and then we can repeat that process, the smallest element, and then we can just keep doing that, 2, 3, 5, 6. But this array is temporary, right? Because they want the answer to be in nums1. So what we could do is then just copy this into nums1. The only problem with this solution is while the time complexity is big O of n, we also need extra memory. We need this temporary array. But is it possible to solve this problem exactly how they want us to solve it without actually needing this temporary array? Because if we don't need the temporary array, we don't need the extra memory. Then the memory would be big O of 1. So let's see how we can solve this problem the most optimal way. Okay, so when you draw it out like this, the first thing you notice is that the empty space is at the end of nums1. So if we're going to start merging these values, why should we start at the beginning and start filling this way when it might just be easier to start filling this way if we want to sort it, because there's already empty space. We know that there's enough space over here for these elements to fit in no matter what, right? That's guaranteed. So I want to start merging from here. So I'm going to initialize a pointer here. This is where we're going to start merging. It's the last value in nums1. Now, what value do we want to put here? Since we want it to be in order, we want the largest value to be over here. How do we get the largest value? Well, we can start at the last real value in nums1 and the last the last number in nums2, because there's no empty space in nums2. And we can compare these two values. We see that 6 is greater. So we don't need this anymore, and we can replace it with a 6. And we also don't need this anymore, so we can move our pointer of nums2 over here now, looking at the 5. And we're also done with this pointer. We can shift it over here. Now we compare 3 and 5. We know 5 is greater, so that's exactly what we can do. We can replace this 0 with a 5. And again, we know we have to shift our pointers now. So the last pointer is going to be over here now. This is going to be the next position we insert into, and this is going to be the next value from nums2 that we look at. So now we're going to compare 2 with 3. Finally, we get a larger value in nums1. So we can get rid of this, place it with a 3. Once again, let's update our pointers. So last pointer is going to be over here now. We got rid of one pointer, replaced it with another. This is going to be the value we look at in nums1. And this time, they're both equal, 2 and 2. So it doesn't really matter which one we replace. I'll use the first one. So get rid of this, get rid of this, and get rid of this. Replace it with a 2. Now we got our last two values. 1 and 2. 2 is greater, so we have no more values in nums2 to look at. We can insert this 2 here. And so we're pretty much done merging because there's no more elements left in nums2, but we only did 5 values, right? Lucky for us, the 1 that's over here doesn't really need to be changed. So we can leave it there and our result is correct regardless. Okay, so now let's finally code it up. So in this function, we're given nums1, we're given m, which is the index of the last value in nums1, not the length of nums1, because we know it has some empty space at the end. We got nums2, and we have n, which is the index of the last value in nums2. So the first thing we want to do is get the last index of nums1, like basically the length. So I'm going to store it in last. Different way, you might need to do m plus n minus 1. So the next thing we want to do is start merging them in reverse order. So now that we have all 3 of the pointers we need, last, m, and n, let's start merging. We're going to keep going while there are elements left in both arrays. So while m greater than 0 and n is greater than 0. We want to find the largest value. So if nums1 of m is greater than nums2 of n, then we can go to our last position, replace it with nums1 of m. The else condition is if they were equal or if nums2 was greater. So in that case, we just want to do the opposite. Nums1 last, it's going to be nums2 of n. One thing we should definitely not forget about is updating our pointers. So since we're going in reverse order, we're going to decrement m and decrement n. Regardless of which element we insert, we want to decrement last regardless. So now we've merged them and into inserted order. We did it without extra memory and the result is stored in nums1. But there's one last edge case that we forgot about. Let me show you. So it was convenient for us that the smallest value was already in the position we wanted it to be in. But what if these two values were the opposite? What if this value was a 2 and this value was a 1? What would we have done in that case? Well, we see that the 2 is greater, so we would get rid of this and then put a 2 here. But notice now how the empty elements are in nums2 over here, right? So in this case, what are we going to do? We're basically just going to take all the remaining elements in nums2 and then fill nums1 with them, right? So we'll just put this 1 over here. In this case, there's only 1 value, but if there were more values, we would just keep going. We would keep taking each value and filling it because this is already in sorted order. So we can just take that sorted portion and then fill nums1. That's exactly what I'm going to do. So fill nums1 with the leftover elements in nums2. And we're only going to do that if there are leftover elements, and the condition for that is if n is greater than 0. So in the last position, nums1 of last is going to be nums2 of n. And then all we need to do is update our pointers. So n and last are both going to be decremented by 1. And hopefully this is bug free. Okay, so this is actually not too bad of a bug. We remember that indexes start at 0, so we forgot to use the -1 in I think most of these, so let me not forget. And now it should work. Awesome. So I tried to make this code somewhat more like readable and beginner friendly. There are definitely more tricky ways you can do this. As always, thank you so much for watching. Please like and subscribe to support the channel. It helps out a lot, and I hope to see you pretty soon.